we've got some more math problems for you. The first one on the page says a 6.2 pound cat needs 2 grams per kg of mannitol IV over 30 minutes. Mannitol is 20%. What are the milligrams? What are the mils? So like always, we're always going to ask what is like and what needs conversion. Well, we already know that 6.2 pounds, we never do pounds. Let's get a new color here. Here we go. 6.2 pounds needs to be converted by 2.2, and that will get us 2.8181. Oh my goodness, it keeps going. So, I suppose for the VTNE, I would say go as far out as you can, which means I would go to 2.8 and then round at the thousandths, or tens, hundreds, thousands. Oh my goodness. How about the hundredths place? 2. And then this can stay blank, which is the thousandths place, because I can't imagine your answer going out that far. But for now, we're going to do reasonable rounding. 2.82 kgs. Okay, we know that always has to be what it is. What else is like, or what needs conversion? Well, we're not too used to grams per kg, are we? That's something that is pretty unique to mannitol. But when you have gram, and you're going in either direction, from gram to milligram or milligram to gram, it is always a conversion factor of 1,000 of some kind. It's either times 1,000 or divided by 1,000, one way or the other. So how I look at it is that a gram is going to be much larger than a milligram. Therefore, 2 grams becomes the much larger 2,000 milligrams, because we're going 3 places or 1,000 times bigger. So if I have 2 grams, I'm going to go, well, hang on, this is how I learned way back in elementary school. 2 grams can be written like this. Okay, got it. And then if I'm going to go to the much smaller milligrams, which actually becomes a really big number, we're going to go 1, 2, 3. We put my decimal place there, put a 0 to be a placeholder, and then we fill in the bumps. That becomes a comma. Now we have 2,000 milligrams. And I know you're probably laughing at me. That's okay. That's how I remember it. Same if it said it's 2 milligrams, but I got to go the other way. I got to go to grams, which is a huge difference. And 2 milligrams converted into grams, well, that gram number is going to be incredibly small. So, if I do the same idea here, I've got 2 milligrams, but I'm going to go this way. 1, 2, 3. Put my decimal place and a 0 as a placeholder. Fill in my zeros, take away the extraneous, and now I have 0.002 grams. Okay? Now, if that isn't quite second nature to you yet, I understand. I had to get myself a chart like this and sit there and go, okay, what's the difference between the base unit, or gram, and a milligram, or even a microgram? What's the difference? Am I going 3 places to the left? Am I going 3 places to the right? So if I'm going from gram to milli, I'm going 3 places to the right. 1, 2, 3 bounces, as you saw. If I'm going from milligram to gram, I'm going to go 1, 2, 3 places to the left. That's where these bouncing ideas come in from way back when I was a kid. So, if that helps you, get yourself a chart, hang on to it, and start getting used to it. Get it in your brain so that it's just second nature to you. But we go back to our question, and 2,000 grams, milligrams is needed per kg. Excellent. Now, the thing is, I know I'm going to need milligrams at some point because it asks to give a milligram as part of my answer, right? But what is this? What is this hot mess? 20%? Well, percent is always the same as a concentration. So anytime you have weight times kg divided by, weight times dose divided by concentration, your concentration can be a percent. It can be a microgram per mil. It can be a mig per mil. It can be any of those things. However, percent, unless it's told you need 2% per kg, and then you could somehow figure it out from there. See, it doesn't work because we don't have how many mils, mig per mil, in any of these answers, right? So what is the easiest? Well, you take your percent and you are going to convert that. And if you remember, percent is exactly the same as grams in 100 mils, meaning somebody took mannitol in its granulated form and said, okay, what are we going to do? How much are we going to weigh this out? Okay, well, I'm going to say we're taking if it's 20%, I'm going to take 20 grams, and I'm diluting it out into 100 mils, and I'm going to shake, shakety shake, and I'm going to create the thing that is known as 20%. Okay, great. But that doesn't help me because 20 grams in 100 mils is not the same as mig per mil. Well, don't worry, because we already know, again, 20 grams, we're going to add 20,000 milligrams in 100 mil. Okay, now we got mig per mil. We are very used to that. We like mig per mil. Now we're going to take away some zeros because that will land me with 1 mil. I like that. I like everything to be in just 1 mil because it has to be per mil so I can get an answer. So now I've got 200 mig per mil. Perfect. And that makes sense. That makes sense, right? If we are seeing something like Baytril, 2.27%, and you've worked a lot with Baytril, you know it's automatically 22.7 mig per mil. We just move that decimal, boom, 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 1 over. So if it says 20%, we're just moving that decimal 1 over to the right, making mig per mil. Okay, so now we have this as 200 mig per mil. Wonderful, we can work with that. So now, do I have all my pieces? I have a weight in kgs. I have a dose in mig per kg. I sure do. And I have my concentration change from a percent into a mig per mil. All right, so 2.82 kgs times 2,000 mig per kg. And remember, we can stop here and get our milligram answer. So we'll go back to our calculator. 2.82 times 2,000 will get me 5,640 milligrams. Excellent. And now we take 5,640 milligrams, and the second part of my equation would be divided by my concentration, which again, percent is a concentration, but it's not like for like. So we had to convert it to mig per mil. 200 mig per mil. And now we go back. 5,640 divided by 200. We'll get an answer of 28.2 mil. Excellent. Those were our two answers. 5,640 mgs and 28.2 mils. And for those of you who haven't worked with mannitol yet, yes, a cat really would get nearly 30 mils of mannitol. Mannitol is something that has to be given very slowly, though. Large volume, very slowly, usually over 30 minutes with a filter. And that's just some bits of information for you in case you do ever work with mannitol. It's very startling to do the math and see that an average cat's going to get 30 mils of anything, because we're so used to the average cat getting a mil or less of nearly everything. So this is the one time that I can really think of when the dose is quite high, but it's also normal. Okay, the next question. This is a very VTNE question because it requires zero math. I should say very minimal math, nothing that you're going to need a calculator for. This is all about critical thinking. Critical thinking. So let's read through it. A cat 4.3 pounds needs methylprednisolone or solumedrol. Dose is 20 mg per cat. Solumedrol comes as 20 mg per mil or 40 mg per mil. So they want to know then, down here in these answer section, that they're going to give you answers A, B, C, D, or answer 1, 2, 3, 4. You're going to pick the best one. So let's read the first one and see if we can figure out where are they going with this. You're going to give 1 cc of 20 mg per mil IV. Okay. You know what? And I missed a part when I was writing this out. Shame on me. No wonder that didn't make sense to me. Period over here. So 20 mg per mil per cat, or 20 mg per cat, it has to go IM. Now it's going to make sense because this first answer said IV. Great, we can throw that answer out because it said IV. Now, why I want you to pay attention so much to reading the entire question and reading the entire answer is because when I was doing these questions, I would have 1000% said, yep, answer number 1 is correct, and I would have moved on. Why would I have said that? Because I read it too fast. If I know that 1, the cat, the whole cat, is getting 20 milligrams, and I already have something that's 20 milligrams in 1 mil, that means the first answer is technically correct, except I didn't read it all the way out to IV, did I? So yes, I can give this entire cat 1 cc of the 20 mg per mil. I can do that, but not IV. Therefore, answer number 1 is wrong. So you see where they try to trick you? If your brain is going too fast like mine usually was on these questions, you start running into problems like that. So let's see what the second one says. Give 1 cc of 40 mg per mil IV. Well, great. We can already not even bother with figuring out math or anything because the question said I have to give it IM, and this answer says IV. 2 is wrong. Don't even have to figure out if 40 mg and 1 mil, none of that. No, no, no. Now the next 2 answers do say IM. Okay, now we know it has to be one of these answers because the question said IM. Perfect. I've just deleted 2 of my questions, or 2 of my answers because they said IV, and I know that's not right. Perfect. Okay, so number 3, give 0.5 cc of 40 mg per mil IM. Okay, well, let's do the math again. They're gonna ask questions like this where the math can be done in your head a lot of the times, and the ones that you can't do in your head, they will allow you a calculator. So if 40 mg per mil is the concentration here, then yes, half of a mil would be 20 mg. and it says I need to give 20 mg per cat. Okay, that math is correct. And it says IM. Perfect. Now, before you just go click happy and say it's number 3, make sure you read number 4. Give 0.5 cc of 20 mg per mil IM. Well, we know that doesn't make sense, because if there's 20 mgs in 1 mil, but I'm only giving half of that, that means I'm only giving 10 mg to my cat. And again, the question said it's 20 mg per cat. So 4 is wrong. The answer is 3. All right. A couple of other things. As you're going to go through this, as you probably have heard me say many, many times, oh, we always have to convert. We always have to convert pounds to kigs, pounds to kigs, da-da-da. But I do say that a lot, except this question, again, they didn't care about pounds or kigs. They said it is the entire dose in a single cat. They might also do this in cattle. They'll say each cow needs 400 milligrams per cow of this drug. Okay, that's fine. Per cow or per cat means weight of that particular animal is no longer an issue. We don't care. We're just saying that within that entire gigantic animal, or inside an entire tiny cat animal, we're just going to give this milligram dosage, and it has proven to be good enough in the long term or short term, or however the question is going to be asked. So in this case, your weight was irrelevant in the question. What is also irrelevant is they're saying methylprednisolone, and then they say solumedrol, but you don't have to know either one of those, because it didn't end up in any of the answers, did it? They're trying to throw you off by making you go, oh God, what is methylprednisolone? Do I have to dilute it? Oh no, what is the proper mg per mil? No, none of that. Just trying to trick you with a little critical thinking. So sometimes when your question seems overly difficult because there's a whole ton of information put into that question, it could be possible they're trying to get you to do critical thinking rather than any type of major math. I know, how awful is that? But it is a very standard question that you'll get a couple of times on the VTNE. Now if we look at the next question, this isn't so much a VTNE question as it is just a real life scenario. And I think I've said to you guys a lot now, weight times dose divided by concentration gives you mils. Oh my goodness, I've said it so many times. So what I'd like to do with this question is to try to get everything done on the calculator all in one. Okay, what do I mean by that? Well, we're going to take that weight times each of these doses divided by the correct concentration, and we're going to get the mils needed. All right, we're going to try to do a lot of this in our brain. Now, I'm not going to ask you to convert 90 down to kigs. I can't do that either. But we get 40.9 kigs. Okay, that's a number I need because all of my questions are what's 0.5 mg per kg of morphine? What is 7 mic per kg of Dexdome? Okay, I need kig. Got it. And then let's see here. If we take morphine first, so let's just go morphine. Bing, bang, boom. You're going to take your 40.9 times the mg per kg, 0.5, 20.45 mg. Oh, I shouldn't make a slash, that's terrible. Colon. And then you're going to divide it by your mg per mil, and it's going to get you 1.36 mils. Okay? That seemed kind of fast, I know. But when you get into your clinical internship or you're in a hospital and you're doing this daily, it's important that you can see this math kind of in your head. Weight times dose divided by concentration gets you mil. And you know each one of those parts so well that you no longer have to write these things out. All right, dextometer. Ooh, if you're looking ahead, you see what I'm seeing. We have kilograms. Yep, we've got kilograms in the number, but this is 7 micrograms. And dextometer here, the concentration is 5 mig per mil. Well, what the hell? Okay, we never fear, because almost always dextometer is going to be written out in doses of anywhere between like 2 to 40 mic per kg. It's almost always written that way. So we just need to memorize that dextometer is going to be 500 mic per mil. Okay? The bottle always says 0.5 mig per mil, as it should. That's easier to write and less difficult to misinterpret if you're reading the bottle fast. But if you memorize in your brain that dextometer is 500 mic per mil, then whenever you run into dextometer 7 mic per kg, you'll go, got it. Kg, 40.9 times dose, which is 7, and that will get me 286.3 mic. Don't forget to label it correctly. Divided by concentration, which I just said is 500, gets me 0.57 mils. Okay, that wasn't too bad. We can get that. So morphine, dextometer, and then ketamine. Okay, so if we look ahead at ketamine and we see we've got mig per kg on the ketamine dose, and then the ketamine concentration is 100 mig per mil. Excellent. So migs are the same, kgs are the same. We don't have a lot to worry about on that one. So we take 40.9 times the dose, which is 2 mig per kg, and we get 81.8 mig. And we divide by concentration, which is 100, and we get 0.82 mils. Okay, so that's where you want to get to as you're doing math, and you keep going over it and over it and over it again. You want to be able to go that fast and get answers this succinctly so that you don't have to write the entire thing out every time. Now, that might be years down the road, and that's fine. You may not accomplish this for the VTNE, and that's also fine. But when you are really practicing your math and you're really trying to be truly as efficient and as accurate as possible, you have to keep practicing it in the same manner every day, exactly the same, with the dose, the concentration, however you want to memorize this equation. So if you want to say kgs times mig per kg divided by mig per mil equals mils, that's great. But don't forget that there's also mic. Don't forget that there's also grams, as we just saw. Okay? But if you want to get really efficient, accurate, then you have to start doing it like this last word problem, so that when you have multiple drugs being given as a pre-med to get this animal knocked out so you can move to surgery, it's got to be a little bit quicker than what you're used to. Okay?